So this APGP to find the sum of the first n terms of an AP, given that the sum of n is equals to Pn plus Q squared. So here actually your P and Q are actually like constants, right? And the sum of 3 terms is equal to 6. Sum of 5 terms equals to 11. So from here you need to find the value of P and Q. So how to find the value of P and Q? Okay, so sum of n, we know that sum of n is equals to Pn plus Qn squared. Okay, so if we're talking about sum of 3, right, that means all you need to do is you take your n out, you put 3 inside. So this will be 3, and this will be 3, and this will be 3. Right, so sum of 3, actually, you can just quickly write this. This is just 3p plus 3 squared is cube, 9, so 9q. This is equation 1. So sum of 5, right? Sum of 5 is 11. You know sum of 5 is 11. Sum of 5 equals 11 means that your n equals to 5, right? Okay, so sum of 5. So again, sum of n equals to Pn plus Qn squared. Sum of 5 equals to 5p plus 5 is 25, right? Okay, so you have 25 q. Okay, this one is equals to how much? It's equals to 11. Right, then for the earlier part, you know that sum of 3 terms is equals to 6. So it's equals to 6. So this one is the first equation, second equation. So all you need to do is you do simultaneous law. Right, so 3p plus 9q equals to 6. 5p plus 25q. So I think I don't have to show you how to do the simultaneous. I think you can do it by yourself quite easily, right? So you can even use GC to help you. You will get p equals to 1.7, q equals to 0.1. So that is for question 2, part 1. Alright, so part 2, okay, given hence or otherwise, you need to find an expression for the n term. You need to find an expression for the n term and the value of the common difference. Alright, so remember in your lecture question, you have learned this before. You know, in general, right, if we're going to find the n term, right, we know that term n, we can rewrite this as the sum of n terms minus the sum of n minus 1 term, right? So the sum of n term is just like, this is term 1 plus term 2 plus term 3 plus term 4 all the way up to plus term n minus 1 plus term n. So minus term 1, sum of n terms. So this is sum of, how about sum of n minus 1 term? Term 1 plus term 2 plus term 3 all the way up to sum of n minus 1 term means you sum up to term n minus 1. So sum of n terms, so you cancel away these two. You see when n terms minus n minus 1 term, you're still going to be left with term n. So actually that's how we actually can use this formula easily. Alright. And so with this, right, do we know what's the sum of n? Actually we do, So earlier on when you found p and q, you know that actually your sum of n is equals to p n plus qn squared. Right, so this is how you connect your story and you solve that p equals to 1.7. You know it is 1.7. Alright, your q is equals to 0.1. This means that your sum of n terms, you can write it as 1.7 n plus 0.1 n squared. Right, so what is the sum? So this is your sum of n. What is sum of n minus 1? Basically, you just take your n minus 1, you replace n with n minus 1. So again, this is 1.7. Instead of n, we put n minus 1. Alright, 0.1 n squared is equal to 0.1 n minus 1 bracket square. Right? So it's very easy. So this is what you do. And then you expand just keep on expanding this. I mean, you can actually do it yourself. You're going to get 0.2n plus 1.6, where your n has to be greater than or equals to 2. Why? Because we have sum of n minus 1. We cannot be n to be 1. Because if we put n, so you think about it, if I put n as 1, so this will become the sum of 0 terms, which doesn't make sense, right? So one constraint you have to consider is you have to put n to be greater than or equals to 2. Alright, I will leave the manipulation here to you. I hope you can do it by yourself. Okay. So with that, you have your, what is this? This is actually your term n, remember? This is your general term. Alright, this is your general term. Okay, and if you're going to find a common difference, it's easy. Common difference, remember, we are just this is an AP, right? If you recall, this is an AP. So how do we find a common difference? You don't, you just take any two terms. Okay, for example, I just take any two terms. Okay, instead I don't use un, I just take any two terms, maybe un minus 1. This is going to give me the common difference, right? So perhaps what I can do is maybe I'll just take let n find a common. Maybe I'll just take u2 minus u1. How about that? All right, and what is u? Okay, remember this is the un that we are finding. Okay, let me rewrite this as a un as well, so we are coherent in the explanation. What is u2? U2 is just substituting 2 in my general term. Alright, sorry, yeah, there's no nothing here. Okay, so it's just u2 in the general term. Right, so what we do, just go sub 0.2 times 2 plus 1.6. Alright, this is my u2. Subtract 0.2 times 1, so there's a plus 1.6 as well. Okay, this is my u1. So u2 minus u1, it will give me the common difference, and doing this by yourself, you can see that my common difference is none other than 0.2. Okay, so this is the common difference, this is my general term, and we have together solved PQ question 2.